Good afternoon. Today I'm going to be discussing my modified Ironwatch RX8004. This watch came with a PT5000 movement and I decided to upgrade it with the Joux-Perret LJP-G100 movement. So why did I do that? Well, Joux-Perret sent me the LJP-G100 movement for review, and as you'll know, I previously reviewed that on my channel. The LJP-G100 is compatible with the Selita SW200-1 and also the ETA 2824-2. So as the PT5000 is effectively a clone of the ETA 2824-2, I knew that the LJP-G100 would be compatible. So I decided to fit the LJP-G100 movement to this watch, which was PT5000 powered, and as you can see, it is working perfectly. Today I completed the modifications and I did the last job, which was cutting the winding stem down to length and fitting the stainless steel screw down crown to the winding stem, and I've now bonded the screw down crown to the winding stem using Loctite 222. So in this video I'm going to talk you through the different tools I used and also give you some tips in case you want to upgrade your own PT5000 powered piece to an SW200-1, alternatively an ETA 2824-2. The same tips apply because all the movements, the architecture is very similar. So firstly I'll explain how I removed the case back, because that was the first obstacle. So I've got this Caseback Removal tool set, and it's a header pie 557, which is a 5537, which is a clone of Bergen's 5537 set. So this is made in China and the quality is excellent. Now, I didn't want to pay for a Swiss-made Bergen sets because they're very expensive just to remove a case back. So I bought these from AliExpress, and as you can see, they're very well made. Now, the problem is the largest size, which usually removes most case backs, as you can see, they have coin edge teeth, which engages with the coin edge finishing on the screw down case back. This size fits most watches, the number 529.5, but it didn't fit the case back on the Ironwatch RX8004, so I couldn't get it off. Now I also have a larger one, which usually does suffice for cases like that where case backs are too big. This one is for Rolex and Tudor case backs. As you can see, it's larger. It's a number 6, which is 36.5, and this is usually the largest caseback tool one would ever need, because Rolex casebacks with coin edge teeth are generally the largest, and this one's too big. So I had a problem because it's an odd size on the Ironwatch. The number 5 doesn't fit and the number 6 doesn't fit. The caseback is in between the two. So I thought, well, how am I going to get the case back off, because I don't have the correct tool. It's an unusual size. It's neither number 5 or number 6, which are in the industry standards. So I came up with a different idea. I used this, which is duct tape. Now this is made by Unibond. It's very strong adhesive duct tape. And what I did was I rolled it into a ball, and I'll actually demonstrate it to you so you can do it yourself. I simply stuck the ball of duct tape onto the case back, as you can see, and then unscrewed it. This actually works as well as one of the header pie tools, as you can see. And it doesn't damage the case back, it comes off, as you can see. So the interior is very well finished. It's lathe cuts, I presume on a CNC lathe, because one can see the characteristic lathe tool cutting to the interior. Absolutely beautiful finish. So I'll show you the movements in the watch. So this is the LJP G100, and as you can see, it fits very well. It's exactly the same dimensions as the PT5000, but it has a superior 64-hour power reserve. The PT5000, being a clone of the ETA 2824-2, has a stated 38-hour power reserve. In practice, I found that the SW200-1, the ETA 2824-2 and the PT5000 all have a 40-hour power reserve typically, even though they are stated as having 38 hours. But nonetheless, the 64-hour power reserve of the LJP-G100 is clearly superior, and it is a higher grade of movement. As you can see, it's Swiss-made rather than being Chinese-made. The PT5000 is made by HK Precision Technology in China, and they've been producing the movement since 2015, but now other Chinese factories are making the PT5000. But the HK Precision Technology version is the original and the best quality. So as you can see, it's running and it's working perfectly. Now, I'm not going to unscrew the crown, and I'll explain why. I've just applied Loctite 222 thread lock to the winding stem, and I've screwed the crown onto the winding stem to bond it on. It takes 24 hours to cure Loctite 222 thread locker fully, and so I don't want to unscrew the crown because I could potentially unscrew the crown from the winding stem, which would cause a problem because it then would have thread lock on it that I can't remove. So with regards to the compatibility, I'm going to explain some things, and I'll show you the PT5000. This is what a PT5000 movement looks like, and as you can see, it's an exact clone of the ETA 2824-2. Now this came from my Ironwatch, and I've looked at the markings very closely, the engravings, and I can confirm that Ironwatch are using HK Precision Technology PT5000s, so they are the original rather than copies made by other Chinese factories, and this is the best version. And the reason why I say that is the PT5000 movements that are coming from HK Precision Technology are lubricated correctly. The problem with the other Chinese factory made PT5000s is often they are not lubricated correctly, and sometimes they're not lubricated at all. And then often collectors will experience an issue. For example, when manually winding the PT5000, the crown winding gear has a lot of friction in it. It feels like it's too much resistance, and that's because there is no lubrication lubricating the crown winding gear. And then, of course, inevitably, the movement fails because of lack of lubrication. But this one is very well lubricated because it is made by HK Precision Technology. And as you can see, it's running because I have removed the winding stem, which I'll show you. So an exact clone of the ETA 2824-2, it has 25 joules and it runs at 28,800 vibrations per hour and a frequency of 4 Hz. The only difference between this and the Sellita SW200-1 is the SW200-1 has 26 joules. They add an extra joule to it, but really I regard that to be negligible. It doesn't enhance the performance. It does take some of the load off the crown winding gear, but really the positive effect is negligible. I really don't think there's any difference in terms of performance between the ETA 2824-2 and the SW200-1. The PT5000 really is equal quality in terms of build quality, quality control, finishing and materials to the 2824-2. There's no difference whatsoever. Many of the parts are interchangeable because the architecture is identical between the two movements. But however, there is a difference between the PT5000 and the LJP-G100. The architecture is different, so the parts are not interchangeable. And I found this out myself through trial and error because no one's done this before. This is a world first, fitting an LJP-G100 movement into a PT5000 watch. This ring, I'll show you where it goes on the movement and then you'll understand what I'm talking about. This spacer ring goes on top of the PT5000s, and the ETA 2824-2 also has this spacer ring, and the purpose of the spacer ring is it raises the dial off the date wheel, and that prevents the date wheel catching on the underside of the dial. It acts like a washer, so it's a spacer ring. And otherwise, if you press down the dial feet engage with the locks, and then what happens is the dial is pulled down tight to the bridge of the movement. But the problem with that is the dial would then compress the date wheel and the date wheel would stick. So the spacer ring allows for some gap between the underside of the dial and the rotating date wheel. Now, I didn't know this, so I actually tried to fit this spacer ring to the LJP-G100, and I couldn't understand why the dial feet weren't engaging in the movements, because I thought, well, the dial feet position is correct. I'm fitting the dial in the correct orientation, so therefore I should be able to lock down the dial. And initially I couldn't do it, and it took me a while to figure out that there was actually a difference in the architecture of the movements, and that the LJP-G100 doesn't need that spacer ring. It actually has a spacer ring which is made into the movements, so that spaces the dial off the date wheel, and therefore it doesn't need an extra spacer ring. So after I figured that out, I was able to then locate the dial correctly and lock it down to the movement. But with regards to the architecture, although it's different, it has the same locking mechanism, locking it into the movement holder. There are 3 flathead screws, one there, and one there, as you can see. And one uses a 1.6mm screwdriver to screw down the tabs and the flathead screws, and that then locks the movement into the holder ring, which locks it into the case. So it is exactly the same diameter as the ETA 2824-2 and the SW200-1. However, there is one notable difference. The winding stem from the PT5000 is not compatible with the LJP-G100. They have different designs of winding stem. So my advice to you is do not insert the winding stem from an SW200-1 or an ETA 2824-2 into the movement, the LJP-G100, because you will damage the keyless works. Now, fortunately, I had discussed this with LJP-G100, Le Joux-Perret, and I inquired about this. I said, is the winding stem compatible between a SW200-1 and the LJP-G100? And they said, no, it isn't. The winding stems are different. So I knew I was going to have to cut down the winding stem to length and also fit the crown to it. So in order to remove the crown, the screw-down crown from the winding stem of the PT5000, I purchased one of these from Amazon. This is a pin vise, and the pin vise has a collet system, as you can see, which holds the winding stem. So for reference, this is what a PT5000 winding stem looks like, which is exactly the same as an ETA 2824-2 and a Sellita SW200-1. Those three movement winding stems are all compatible. They are the same design. So I had to use this pin vise to grip the winding stem, and then I unscrewed the screw down crown off it because I needed to recycle it to use it on the winding stem of the LJP G100. Now you might be wondering, why have I got blue tack on the underside of it? Well, I'll explain why that is. What I did was I used the blue tack to stick it down to the desktop so that it wasn't rolling about, and I didn't need my left hand to hold it in position. And the reason why I did that was I cut it down to length using a Dremel. This is a Dremel 3000, and for reference, if you're going to be cutting winding stems, use it on speed number 6 of 10. That is the perfect speed. And as you can see, I've got a carborundum cutting disc, and I cut the winding stem and ground it to length using this cutting disc. Now, this isn't the conventional method, and I want to give you the background to my watch modding, and then you'll understand that I don't always take the professional route. I often come up with my own ideas, and as I've shown you, one of those ideas was using a ball of duct tape to remove the case back. Watchmakers aren't going to think of that. So I watched some YouTube videos of professional watchmakers because I've never cut down a winding stem with a movement, and I didn't know how to do it. And I saw lots of watchmakers using end cutters, which are like pliers, and they cut down the end of the winding stem using the end cutters, and that blunts it. It gives a tapered effect, which I don't like, and I thought that's very unprofessional. And then what they do is they file down the end of the winding stem. They grip it in a pin vise, which I showed you, and then they use a file and file down the end of it, either into a domed cap or a conical profile, or alternatively they file it down flush so it's flat. Now, I don't like that method because cutting it with the end cutters is very amateur. Now, what I did was instead I inserted the winding stem into the movement, and I pushed it in fully to get it into the correct position, which is with the crown closed. And then I used this. This is my digital caliper vernier, and the blades are made from carbon fibre. This is the digital caliper vernier I use for measuring the watches when I review watches to get the case dimensions, lug-to-lug measurement, thickness, etc. correct. I'm often queried on the dimensions of watches I review. For example, people say, on AliExpress, this Pagani design is listed as 41mm, but you've said it's 40mm. You know, you're wrong. And I can tell you that I have produced 216 reviews, over 200 watches. Every single watch I have reviewed on my channel, I have measured using this digital vernier caliper. So when I say a case is 41mm, you can take that as fact. I haven't taken the specification off AliExpress. I've actually measured it physically myself. Because often with AliExpress, the resellers are incorrect with their specifications, and especially Pagani design resellers, they're notorious for listing a 40mm case as being 41, etc. Now, the reason why I use a carbon fibre bladed digital vernier caliper is it doesn't scratch the stainless steel case of a watch. I do also have a metal stainless steel digital caliper vernier, but the problem with using metal blades is they will scuff and scratch a watch. So I very accurately measured the length of the stem, and what I did was I pushed it into the movement, and I used this side like so to measure the distance between the case and the underside of the crown. And so as you can see, for example here, it's showing the length as 10.4mm, and then I knew that I needed to subtract 10.4mm precisely from the winding stem, and then screw the crown on, and that would give me the perfect length. Now, I measured it once and I cut it once and I got it correct the first time. And I didn't use end cutters and file it down as per watchmakers. I simply used my Dremel and I marked it using a Sharpie pen, cut it in one cut, and then I ground it down to the mark with a Sharpie pen, and I got it correct. Now, I then bonded the stainless steel crown onto the winding stem using Loctite 222. Now again, there's a plethora of information on YouTube from professional watchmakers on which is the correct thread locker to use. For example, some use 242. Personally, I prefer to use 222. I also use this in screw pins in bracelets to lock them in the bracelet from unscrewing accidentally. The reason why I prefer 222 is, although it is thread locker and it will lock the screw in effectively after it's cured for 24 hours, it's low strength, so that means one can potentially unscrew the screw again. So for example, in a bracelet, if you're resizing a bracelet and you want to remove a link or add a link and you use the screw pins, you dip the end of the screw in the thread locker, screw it in, allow 24 hours for it to cure fully. If you do in the future want to remove it, you can remove it using heat. So I use a blowtorch, a butane blowtorch, to heat up the screw. That will disintegrate, it melts the thread lock, and then one can unscrew it without chewing the screw head or stripping the thread on the screw. So 222 is better because it's low strength. Although it does lock the screw in, you can heat it up with a butane blowtorch and actually undo the screw after. So what I did was I dipped the end of the winding stem into a pool of 222 thread locker, and then I screwed the the crown onto the winding stem to lock it on, and it's now curing and it will continue to cure fully for the next 24 hours. So I'm able to screw it down fully, and as you can see, the movement's running and it is the correct length because it is screwed down all the way to the case with no gap. So I was able to reuse the stainless steel crown, and I have used the winding stem from the Joux-Perret LJP-G100, and as you can see, the movement's now running correctly. I fully wound it and it will continue to run for its maximum 64-hour power reserve. I regulated the movement in 5 positions as per COSC limits, and I can tell you that it's running within COSC chronometer limits of -4 to +6 seconds per day. It's running consistently at +2 seconds per day, which is outstanding accuracy. It's chronometer grade. So 64-hour power reserve +2 seconds per day, it's an outstanding movement. So I'm just going to screw back on the stainless steel case back, and this is another thing I use. This is a blower. These are inexpensive to buy from AliExpress, eBay and Amazon. This is just a generic one I bought from Amazon. And I use it to blow away dust and lint prior to fitting the case back, because that will ensure that the movement isn't contaminated with dust particles, which will make the lubricant dirty and therefore increase friction in the movement. So as you can see, it's easy to screw down the case back just using the ball of duct tape. One doesn't need to use a tool. It's actually surprising. One can get good purchase because it's very sticky and it's easy to tighten it down fully. That's enough. Now, of course, it does leave some residue. So in order to remove the sticky residue of the adhesive from the duct tape, I use this. This is just nail polish remover. Now, the main ingredient in nail polish remover is acetone, which is a very powerful solvent and ideal for dissolving glue and adhesive residue. So what I would say to you is, after you use duct tape on the case back, simply use this acetone on a cotton cloth. It won't damage or etch the 316L grade stainless steel because that's corrosion resistant, it's resistant to chemicals. But the acetone is very effective. It will clean up the stainless steel to a flawless finish. So I just use acetone to remove the adhesive, and that is a credible alternative to using one of these case back tools. And of course, it doesn't damage the case back, it doesn't damage the teeth if one slips. So with regards to the other tools I use, I'll talk you through some of the other things. This is Rodico putty. It's made by Bergen, it's Swiss made, and it's rather like plasticine, but it doesn't leave any oily residue. Now what I do is I roll this into a conical shape, and the reason why I do that is I actually use this as a tool, not just for cleaning up the dial and the hands and removing grease and lint. What I do is I use this to set the hands on the cannon pinion, because it's very difficult to pick up watch hands when setting them on the cannon pinion using a needlepoint tweezers, which I'll also show you. I use these stainless steel ones. They're made by Vitus, as you can see. And they're very good because they've got very fine precision ground needle points. Just bear with me, I'll get the camera to focus. And they're good for picking up small parts like watch hands or screws. As you can see, now it's focused. So I use this for picking up the screws, for example, or picking up the hands, but in order to set the hands, it's actually quite difficult. And the risk is one can scuffle scratch the hands or scuffle scratch the dial using the needlepoint tweezers. So I use this Rodico putty. I stick the end of the Rodico putty onto the hand, and then I can move the hand about precisely with my left hand. And then I'll show you what I use to actually set the hands on the cannon pinion. This is a hand setting tool. Now you can buy tools which are like a press, but I prefer to do them freehand as per a professional watchmaker. It does take some practice, but I can now do it by feel. So to give you a background, I'm not a watchmaker, but I've got several years of experience modifying watches. I started modifying Seiko SKX007s in 2016. For example, changing the crystals, the bezels, and also the movements, upgrading the 7S26 to a 4R36, for example, to give it hand winding and hacking. So just bear with me, I'll try and get the camera to focus. And this is the pressing tool one uses to set the hands. It's got a nylon end with a hole in the end. There are two different sizes. The larger hole is for the hour hand. So the hour hand goes on first, then you press on the minute hand on the cannon pinion, and then after, lastly, use a different tool with a brass end. I'll show you. Just bear with me, I'll try and get the camera to focus on it. And the brass end pushes the second hand into the cannon pinion. There we are, it's focused. And the brass is soft, so it doesn't scuff or scratch the hands, which are usually made from laser cut brass, which is electroplated. Sometimes it's rhodium plated on higher quality watches, but on low tier and mid tier watches the hands are generally made from laser cut brass, which is then electroplated with nickel, as you can see. So it has a brass end. So this is for pressing on the second hand into the hole in the cannon pinion. I'll just show you the other one again so you can see it for contrast. Try and get it to focus on my finger again. There we are. So as you can see, the end of the tool is made from nylon, which is soft, so therefore it doesn't damage the cannon pinion and it doesn't damage the hands when pressing them on. It's a soft tool. But the large hole is enough to allow the cannon pinion to go inside the tool, and therefore one can get the alignment correct when pressing the hour hand on. The other hole is smaller, and that's because as the cannon pinion goes up in height, it reduces in diameter. It's wider at the base for the hour hand, which has a larger hole. The minute hand has a smaller hole. And then finally, the second hand presses into the top hole in the cannon pinion, which is the smallest of them all. So I use those two tools and I press them on by hand. Now, as you can see, the PT5000 hands are compatible. I was able to recycle them, and I'll show you how I remove them from the cannon pinion. I use this. This is a Presto tool. And this is just a generic one. Bergen make very high quality, Swiss made, professional grade watchmaking hand tools. So this Presto style of tool is a very effective design. I really like it, but I didn't want to pay for a Bergen one because I very rarely fit hands to watches, even though I have done it many times with Seiko SKXs, and then I moved on to Vostok Amphibias, and then I moved on to modifying Steinhardt Ocean 1s. But I like the design. I'll just show you the tip of it, how it works. Just bear with me, I'll get the camera to focus on it. It's got a nice spring-loaded action, and it has the effect of prising off the hands off the cannon pinion all in one go. So one can remove all three hands, the hour, minute and second hand, in one pull. And I like this style of tool. It grips the hands underneath the cannon pinion very well without damaging them, and I was able to recycle them. Now, this is something again that I differ in my opinion. Professional watchmakers, I've watched videos of trained watchmakers removing hands using this tool, using a Presto tool. And I don't like the method they use. They use a dial protector, which is made by Bergen. It's basically a disc with a slot in it which slips underneath the handset and around the cannon pinion, and that protects the dial in case you slip with the Presto tool and you scuff the dial. I don't like that method. I actually came up with a different method which I think is better. This is just a piece of Ziploc bag, a plastic bag. And what I do is I lay the plastic bag on top of the hands, and I hack the movement, so I stop the second hand dead so it's not moving around the dial. And then I push down the Presto tool through the plastic onto the cannon pinion, onto the hands, and I squeeze it in one squeeze, and that lifts off the hands, but the dial is protected by this piece of plastic Ziploc bag. So if one slips with the tool, one doesn't scuff the dial. It has the same effect as a dial protector, but being a piece of plastic bag, it's thinner. And so therefore the Presto tool can actually grip through it. And one can grip the three hands and lift them off in one go with a plastic bag like this. And it protects the hands from being scuffed by the tool as well. So I actually think it's a superior method. And as I've discussed, I'm not a watchmaker, but I prefer to use my own method sometimes, such as the plastic bag and the Presto tool rather than a dial protector, and such as using a ball of duct tape. Because if it does the job correctly, why not use the method rather than using the method that watchmakers say is the correct method, which might not actually be as easy. So the other thing I use is these Bergen Swiss-made screwdrivers. Now these are professional watchmaking screwdrivers. The 1.6 is my favourite. It's the most common one because it's the ideal size for resizing bracelet screw pins and also general screws in watches. For example, the movement holder rings in watches are generally 1.6mm, but I've got the set from 0.8mm to 1.6. They've got hardened tool steel tips, which are precision ground, and the shanks are made from knurled stainless steel. One thing I like about these Bergen screwdrivers is the nylon head rotates. It's got a ball bearing race inside underneath the nylon head, and it's silky smooth. The purpose of that is one can fit the nylon head into the palm of the hand and then use one's index finger and thumb to precisely rotate the end of the screwdriver under control, so one isn't going to slip with the screwdriver tip and scuff a bracelet, for example. And I really like the quality of these Bergen screwdrivers, and they're inexpensive to buy on Amazon. I bought this set on Amazon and I've used them for the last 5 years. And the tips are replaceable, so when they go blunt you can either file them or grind them down to a point again, or you can simply buy the replacement tips and just change the tip rather than changing the whole screwdriver. So Bergen screwdrivers are professional grade, they're a worthwhile investment. So, is there anything else to show you? That's it, I think. I've showed you all the tools I used and I've given you all the tips. So, as you can see, the movement is continuing to run correctly. It's got a nice smooth sweep to it because, like the PC5000, the LJP-G100 runs at a frequency of 4 Hz. And one thing I like about 4 Hz movements is that they have a characteristic smooth sweep. With Seiko movements, they run at a 3 Hz frequency, and that is 21,600 vibrations per hour. I personally prefer 28,800 vibrations per hour as the beat rate and the frequency of 4 Hz, because as you can see, looking closely at the second hand, it has a smoother sweep around the dial. With Seiko movements running at 3 Hz, the second hand judders or stutters slightly more, so it's not as aesthetically pleasing. But there's another reason why I prefer 4 Hz movements like this LJP-G100. I regard 4 Hz to be the sweet spot. It's the perfect compromise, the perfect balance between power reserve and accuracy. With watch movements, automatic movements, there is a balance between power reserve and accuracy. High beat rate movements have better accuracy than low beat rate movements. The negative of a high beat movement is, of course, one exhausts power reserve quicker. So when one gains the beat rate, one sacrifices power reserve. When one lowers the beat rate, it has the effect of extending the power reserve. So one has to balance between the two, power reserve and accuracy. Now 4 Hz gives a very good balance. It gives a good compromise. This one, for example, is 64 hours power reserve, but it still has the accuracy of COSC chronometer limits of -4 to +6. I've regulated it in 5 positions to +2 seconds per day. So one can get the accuracy and one can also get the power reserve. And what I like about the Joux-Perret LJP-G100 is they have managed to do something that Sellita and ETA could not do. And that is to increase the power reserve of a movement which is the same size as an SW200-1 or an ETA 2824-2, increase the power reserve from 38 hours, which is the industry standard for automatic movements, to a massive 64 hours, but still retain the accuracy. This can still be regulated to within COSC chronometer limits. So, this is a world first, the Ironwatch RX8004 with a 64-hour power reserve and also COSC chronometer limits. This is +2 seconds per day, the only one in the world to have it. So I'm absolutely delighted with it, and what I'm now going to do after the crown has fully cured with the Loctite 222 thread locker is I'll refit the bracelet with the spring bars, and then I'll wear the watch and test it out. But so far it's running very well. I've observed it, and the 64 hours really is 64 hours, and also the accuracy is consistent at +2 seconds per day. Now there is something to discuss with regards to accuracy. When power reserve exhausts, for example, when the main spring begins to discharge, when it becomes exhausted, for example, when 64 hours becomes 40 hours, becomes 30 or 20 hours, inevitably the accuracy is lost. It becomes less accurate the more the main spring is unwound. It's a given that watch movements are at their peak accuracy when the mainspring is wound to its absolute maximum, because it has the maximum amount of power in it to provide the movement. So, for example, this is a reason why I dislike COSC certification used by Rolex. For example, my Submariner uses the caliber 3230, which is a chronology movement. It's an incredibly efficient movement. And of course, it is certified after casing by COSC as being -2 to +2 seconds per day, well within COSC chronometer limits. And then it's also self-certified by Rolex as a superlative chronometer. But the reason why I dislike COSC chronometer certification is they only test the movements after casing when they're fully wound. So, for example, they will take my Submariner with a caliber 3230 and they will observe the accuracy of the movement when it's wound to its maximum 70 hours. And it's a given that that movement, the 3230, will perform at its absolute best when it has 70 hours of power. When that movement's only running at 10 or 20 hours, it isn't performing as well because it doesn't have as much tension in the mainspring. With Omega, I actually prefer them using METAS chronometer certification. For example, the Omega Seamaster and the Omega Planetocean are METAS certified as master chronometers. And I regard METAS certification to be superior to COSC. The reason why is METAS don't just test the movements after casing when they are 100% at their maximum power reserve. They also test them when they're at 30%, when 70% of the power reserve has been depleted. And the reality is that's a more real life situation, because often we'll wear watches when they're only at 30% of their power reserve. For example, you might not wear a watch 8 to 12 hours per day to top it up to its maximum power reserve. It might only be running at 30% most days. And I like that about Omega. They don't just test their movements to master chronometer limits when they're at 100%, they test them when they're at 30%, which is a truer representation. So I like the fact that the caliber 8800 is a master chronometer master chronometer Omega movement certified by METAS, and I actually regard it to be more thorough than the COSC chronometer certification used by Rolex in their chronology movements, such as the 3230 and 3235 used in the Submariner and Submariner date respectively. But with regards to the Joux-Perret LJP-G100, it is perfectly capable of attaining chronometer and top grade. And in fact, Joux-Perret offer the movement in 4 grades, the same as Sellita and ETA. So just to give you an idea, in case you're not aware, movements such as the SW200-1 and the ETA 2824-2 come in 4 grades: standard, elabor, chronometer and top grade. Top grade, as the name suggests, is the very best. Now, the reality is the movements are exactly the same. The only difference is the number of positions they are regulated in. 5 positions is the top regulation. So the top grade and chronometer grade movements are regulated in 5 positions, and of course that gives them the best accuracy within COSC chronometer limits. I've done the same with this LJP-G100. I've moved the watch into the 5 standard COSC chronometer positions, and I've regulated the movement in all of those 5 positions to get it to +2 seconds per day, which I'm satisfied with. So it's chronometer accurate. It's equal in quality to the SW200-1 and the ETA 2824-2, and also I would say it's equal in quality to the PT5000, which I'll just show you again. And lastly, I just want to explain something about it you might not be aware of. I do refer to this in my reviews of watches with the PT5000, but you may not have seen those reviews, so I'll just explain something. The PT5000 has been produced since 2015 by HK Precision Technology, as I've discussed. But it came to global attention for positive reasons in 2018 because a Chinese watch brand used the PT5000 in a watch which was observed at the Glashütte Observatory in Germany, and it was certified as a chronometer. And it was the first Chinese-made movement certified as a chronometer at the Glashütte Observatory. Now, usually METAS and COSC are used to certify movements as being chronometer accurate, but of course they only certify movements that are Swiss made. Because the PT5000 is Chinese made, COSC and METAS would refuse to certify as a chronometer. They only allow Swiss made movements. So, as an alternative, the Chinese brand took the movement in a watch to the Glashütte Observatory in Germany because they also certify movements which are made outside of Switzerland, such as China. And it proved a good point because the quality of the PT5000, the build quality, the quality control, the finishing, the materials are exactly the same as the ETA 2824-2, which it is a clone of. And the only difference is this is made in China rather than being made in Switzerland, but really it can do exactly the same thing. It can attain -4 to +6 seconds per day. But of course it's significantly less expensive. So for reference, how much is a PT5000? Well, I looked on AliExpress today and one can purchase this PT5000 for €72. It is incredibly inexpensive. And this raises an interesting point because to service an SW200-1 every 5 years or to service an an ETA 2824-2 every 5 years, the typical service cost is €150. For example, if you have a Steinhardt Ocean 139 with a 2824-2 or an SW200-1, you return the watch to Steinhardt and they charge you €150 to service the watch. They'll polish all the scratches out of the head of the piece and the bracelet and also strip down the movement, ultrasonically clean the parts, build it back up with fresh lubricant and regulate it to the 3 positions of a lab ore grade. €150. But the advantage of the PT5000 is one doesn't need to break down the movement and ultrasonically clean the parts and then build it back up. One can simply throw it away. Because at €72, that's the retail price. One can simply remove the movement and fit a new one every 5 years. One doesn't need to service it. So it's actually a more cost-effective movement for brands to use the PT5000 rather than the SW200-1. Because it's €72 to replace it versus €150 to service the watch. Now, of course, that's the retail price. The wholesale price is a lot lower than that, and I'm privy to that, but I'm not going to reveal it to you because it's trade only. I can tell you with regards to the LJP-G100, the wholesale price per piece is very similar to the SW200-1 from Sellita. And it's an inexpensive movement. Now, it's more expensive than the PT5000, but it's less expensive than the ETA 2824-2. So good compromise between them, but of course better power reserve at 64 hours. So that's all I have to say. I hope you've enjoyed my review of my modified Ironwatch RX8004 with the Joux-Perret LJP-G100, the only one in the world, 64 hours of power reserve plus 2 seconds per day. Please feel free to post your own comments below the video. Thank you very much.